Hi, this is a reply to Mr. Garg Universities. Predicts stock market with mathematics and statistics. He made a number of them. He had his formulas particularly wrong, and basically it was dangerous. A lot of people, there wasn't many, but a few people replied, and they thought it was really was a prediction, or that there was some good in it. It really wasn't. It was basically all wrong. Now, I've downloaded the SPY because I couldn't reproduce his data. I don't know what it was. The SPY is generally correlated with the market. It's the S&P 500 ETF. He could have had Indian stocks, I don't know. And anyway, to calculate the daily return, the arithmetic return is today divided by yesterday minus 1. And then you just click percentage to make it a percent. You don't need to do what Mr. Garg did. That wasn't, it was really, I don't know. I'm not even sure he's getting the right answer. Now, the log return, which is a cumulative compounding return or a geometric return, is log B3 over B2. It's slightly different, slightly less there. I haven't rounded it as much there. All the other formulas are the same. Mr. Garg's small formula there. Counting the numbers. Instead of using the numbers, I used L3 over count, because you may want to use the formula over and over again and get different data, but I suggest you don't use it at all because it's wrong. These are not cumulative probabilities. Now, that's ridiculous to say that these things have we're down to where are we? We're up to basically we're up to basically 103, 4, 5, 6, 7, 8, 108 occurrences below 0.001, below 0, and even though I haven't, I've used frequency formula instead rather than the lookup tables. It's the same thing. He does the same thing in another one of his videos. He repeats the same stuff about 3 times. Now, minus 1%, according to him, occurs 8.94% of the time. If out of 248 data points, 100 of them are minus 0.01, how can it possibly be 8.94%? It's almost half. It just beggars belief. It just defies logic, but plenty of people are fooled. I fancied up his ogive. You can see there the red line shows the 0.1. Clearly it's on Mr. Thing's probability, it's 10%. That's ridiculous. Or less than 10%. 0.8%. That's ridiculous. That is one standard deviation. That's one standard deviation to show on Mr. Garg's relative cumulative frequency ogive, which is what it really is, where the bulk of the data lies. You can't get probability frequencies from relative frequency ogives at all. What you can get is a relative frequency. And from this you can get a cumulative relative frequency. Because this point occurs once out of 248 data points. How can it possibly occur with a frequency of, watch this, let's see, I think it's 5%, put in 5%, 0.05, 5%. No, it must be... What is this? Let's have a look. Oh yeah, 5%. 5%, yeah, how can 5% occur 99% of the time? It's only ever occurred once in the whole year. It's clearly his cumulative, he doesn't know what he's doing. Anyway, I knocked up a quick, with a pivot table, a quick probability chart. And I'll go through that again, how to do it, so you can really see how these things are done. Now we'll insert a data point, or insert a worksheet. I suppose I should say a few tips, otherwise I'm pretty well wasting your time. Now, copy the data. There's two quick ways to copy the data. One, go there, shift, end, down. Or another way, which I like to do, is shift, wait for the crosshairs, double click, and down. Control C. Rather than paste, because it'll you want to paste not formula. Oh, we don't want to paste that. That's the. Oh, we'll paste that. We'll do that. Control V. All right. Now we'll do the formulas again, so I can show you how it's done. Equals that divided by that minus 1. Not what Mr. Garg did. Which is at 100%. Then time was crazy stuff. You do that and you click down, and that's what we're after. Now we'll control C that again, because we don't want, for a pivot table, we don't want that. We want just the data, not the formulas. So to quickly paste the formulas, we go Alt H V V. That's the data, not the formula. Now I select in the middle of it. We'll go to Insert, Pivot Table, selects the range, OK, another form. Alright, you get that. Down to rows. You get that, down to values. Now that we don't want sum, we want to change it to count. Change value field settings to count. They're all 1. Click in there, go up to group field. It'll bring up, it automatically put the bins for the histogram, separated by 0.01 intervals. Bang, done. Now you can do a pivot chart quickly. Get a quick semi-histogram. It's not real great. I won't bother mucking around with that much. It's not real useful. None of these slices are any good with this sort of thing, not statistics. So what you're better off doing is actually getting this data, copying the data points. We'll go out here, we'll paste equals that over that F4 to lock it down. Gives you the relative frequency of each occurrence. 1, we don't need that. We do and now to get the cumulative frequency, or Mr. Garg's ogive, but of course it's not the same because he had every data point. We're doing it in frequency bins. And we'll copy that down. Don't want those. Don't want that. Right. So now we've got here's relative frequency, as you can see. The maximum data point, so I printed out the statistics. Where's the data sheet? We'll go up. The max data point was the range. The maximum data point was 0.505. He says is 99% certain. It happened once. Once out of 247 events. How can 1 out of 247 be 99% probable when something which occurs very frequently, like minus 0.002 to minus 0.007, or basically 0.01, basically 135 times out of 208, 54%, the relative frequency of 54%. That has a relative frequency of 0.004%, 0.04 of 1%. How we got 99% certain for that and something like 8% certain for that, I don't know. I mean, it just beggars belief. Anyway, we'll finish the chart. We'll select the data. Recommended charts, all charts, combo, stacked, secondary axis. See a nice bell curve over the data. When you fit the Pareto curve, or is Mr. On the same axis, it makes the probability distribution look small. Here's Pareto curve or ogive, which is not a probability curve, that's the probability curve. Now we'll click and we'll just make it a histogram again. Alright, you can see that it's a cumulative frequency, relative cumulative frequency. It's a Pareto curve or an ogive. It's not a probability. It does not predict share prices. It predicts nothing. It predicts nothing other than the cumulative relative frequency. Now we'll delete it so the probability stands out. The probability fits nicely over the histogram now. We can see the mean is there is actually more 0 days than there is positive days, which is reversed with Mr. Garg. There's actually a relative frequency up to 0 and to minus 0.3. There is 82% of the data. So yeah, he's clearly got it all wrong. Anyway, that's enough for that. I'll just quickly show you how probabilities are actually calculated. Probabilities are actually calculated. Here's an example here. We'll click in there. You can see the formula up here. Probabilities come from underlying distributions. Now, you have to estimate by visualizing the scatter on an XY chart of what the underlying distribution is. In this case, it was clearly pretty well bell-shaped. So it's a normal distribution. So you use a normal distribution to estimate the probabilities. This is actually how you estimate probabilities. The log of today's price over the future price, say a standard deviation or a volatility of 0.1 times square root of 30 days over the trading period of 250 days, an approximation of the trading year. And that's true for the function to calculate the inverse or the I forget the names now, but anyway, that's just a housekeeping measure for the formula. And when you do that and you click on it, you can see you get 42%.